there is a lock protecting roughly $2 trillion. To pick it by brute force, a normal computer, trying a billion combinations every second, would need longer than the age of the universe. Not longer than your life. Longer than every star that has ever burned. This lock guards Bitcoin, and for over 15 years, it has been, for all practical purposes, perfect. But there is a machine being built right now, in labs cooled to colder than deep space, that doesn't pick locks the way normal computers do. It doesn't try every key. It asks the lock all at once which key it wants, and if that machine ever gets big enough, the math that protects Bitcoin, your bank, your messages, the entire internet, stops being a fortress and starts being a formality. So, are quantum computers going to destroy Bitcoin? Let's actually find out properly, because the real answer is stranger than the headline. To understand the threat, you need to know that Bitcoin doesn't have one lock. It has two completely different kinds, and the quantum computer treats them very differently. Lock number one is your signature. Every Bitcoin wallet has a private key, a secret number, and a public key derived from it. Think of the private key as a fingerprint and the public key as the glove it leaves behind. The magic of the math is that it's easy to go from fingerprint to glove, but practically impossible to go backwards from the glove to the fingerprint. That one-way street is what lets you prove you own your coins without revealing your secret. Lock number two is mining, the giant guessing game that secures the ledger and stamps each block. These two locks rest on different math, and here's the part the scary headlines skip. A quantum computer smashes one of them and merely dents the other. Knowing which is the whole story. So, what makes this machine different? A normal computer thinks in bits, tiny switches that are either 0 or 1. To search a million possibilities, it checks them one after another. Fast, but one at a time. A quantum computer uses qubits, and a qubit can be 0, 1, or a strange blend of both at once, a property called superposition. String enough qubits together, and the machine can explore a staggering number of possibilities simultaneously. Then use quantum interference to cancel out the wrong answers and amplify the right one. For most everyday tasks, this is useless. Your email will never need it. But for a few very specific math problems, it's revolutionary. And by pure bad luck, one of those problems, reversing that fingerprint from glove trick, is exactly the one protecting your Bitcoin signature. A clever algorithm designed in 1994 by mathematician Peter Shor turns that one-way street into a two-way street. The lock that needed longer than the universe? Shor's algorithm could open it in hours. Okay, so a big enough quantum computer could forge signatures. What does that actually mean for your coins? Here's the crucial detail almost everyone misses. You are only exposed when your public key is visible. And for a huge amount of Bitcoin, it's hidden. Most modern addresses only reveal a scrambled version of your public key until the moment you spend from them. So the safest coins are the ones that have never moved. The dangerous ones fall into two groups. First, addresses that have already exposed their public key, including very old wallets from Bitcoin's earliest days when the format was different. Second, and scarier, the brief window when you broadcast a transaction. For a few minutes, your real public key is out in the open, waiting to be confirmed. A powerful enough quantum attacker could, in theory, see it, forge your signature, and steal your coins before the network even finishes processing your payment. And the single largest pile of exposed, never-moved coins on Earth? It belongs to a ghost. Quick word from our resident bot, who would like to point out something reassuring. No quantum computer, no matter how powerful, can forge a subscribe. It's not protected by elliptic curves. It's protected by you clicking it. The most quantum-resistant action available to you today is, ironically, the bell. Tap it, and let's get back to the race. Now for the reality check, because the gap between theoretically possible and actually happening is enormous. The quantum computers that exist today are astonishing scientific instruments and nowhere near powerful enough to touch Bitcoin. The problem is that qubits are fragile, almost unimaginably so. The slightest heat, vibration, or stray particle makes them lose their quantum state, an error called decoherence. To run Shor's algorithm against Bitcoin's signatures, researchers estimate you'd need not dozens or hundreds of qubits, but millions of stable, error-corrected ones. Today's best machines have on the order of hundreds to low thousands of physical qubits, and it can take 1,000 or more physical qubits just to build a single, reliable logical one. That is a gap of many orders of magnitude. Most serious experts estimate a Bitcoin-breaking quantum computer is at least a decade away, probably more, and some think it may never become practical at all. The countdown clock is real, but nobody, not Google, not IBM, not the most caffeinated researcher on Earth, knows what number it actually says. Here's what the scary headlines almost never mention. Bitcoin is not a fixed object. It's software, and software can be upgraded. The entire field of post-quantum cryptography exists to build new locks that even a quantum computer can't pick, and it's not science fiction. In 2024, the U.S. standards body, NIST, formally published its first post-quantum encryption standards, ready for the world to adopt. For Bitcoin, the fix is conceptually straightforward, if politically slow. Agree on a quantum-resistant signature scheme and let users move their coins into new, safe address types. Remember, the threat to mining was only a dent, not a smash. A quantum computer would speed up the guessing game, but the network can simply adjust its difficulty the way it already does. The real work is upgrading signatures before the clock runs out. And the beautiful part is that everyone has every incentive to cooperate, because the alternative is everyone losing everything at once. Bitcoin has changed its rules before. It can change its locks. But we promised you the honest version, so here are the genuine problems, the ones that keep cryptographers up at night. First, coordination. Getting a decentralized network of millions of people to agree on a major change and actually move their coins is slow and messy. Bitcoin upgrades can take years. Second, the lost coins. Millions of Bitcoins sit in wallets whose owners are dead or whose keys are gone forever, including, very possibly, Satoshi's. Those coins can never be migrated to safety by anyone because no one can move them. If a quantum computer arrives, those exposed, abandoned fortunes become free real estate, and watching a ghost's coins suddenly move would be the most terrifying alarm bell in financial history. Third, harvest now, decrypt later. A patient attacker could be recording exposed public keys today, planning to crack them the moment the hardware exists. The clock you can't read might already be ticking. None of this is unsolvable, but none of it is automatic either. Preparation is a choice the network has to actively make. So zoom out. Are quantum computers going to destroy Bitcoin? The honest answer is almost certainly not, but only because we can see them coming. This was never really a story about a doomsday machine. It's a story about a race between two kinds of human ingenuity, the people building the lockbreaker and the people building better locks. And here's the part that should make you optimistic. Bitcoin is not the most vulnerable thing on this list. The exact same cryptography protects your bank, your medical records, government secrets, and the encrypted messages you sent this morning. If quantum computers ever break Bitcoin, Bitcoin will be very far from your biggest problem, which means the entire world, every government and corporation on Earth, is racing to solve this together. Bitcoin is just the $2 trillion bounty that makes the race impossible to ignore. The lock and the locksmith have been chasing each other for thousands of years since the first person hid the first valuable thing. Quantum computing is just the newest lap, and so far in the whole history of secrets, the lock makers have always eventually caught up. So here's our question for the comments. Best answer gets pinned to the top. If a quantum computer cracked everything tomorrow, what would you be more worried about losing? Your coins? Or every private message you've ever sent? Be honest. And if you want to know what that $2 trillion bounty is even worth defending, watch what a single Bitcoin being worth $1 million would do to the world right here. The locksmith will keep studying. It's patient like that.